Hello all. My topic for this capstone project is to suggest the best trading options for a particular perishable food crop across the states in India. And coming to the significance of this topic, Indian economy mostly depends upon agriculture. Almost 60 to 65% of Indian economy comes from agriculture. So a very effective trade system is mandatory to regulate the food crop prices. And in particular too, I have chosen perishable food crops because perishable food crops need to be transported within 1 to 2 weeks of harvesting. So a very efficient and planned trade system is necessary to regulate the food prices for a particular for these perishable food crops. And my strategy to solve this issue is to design a machine learning algorithm or the model which can suggest me the best set of states to trade a particular perishable food crop in India. For example, in case of exporting a particular food crop, I want my model to suggest the best set of states to trade with, so that the farmers will be getting the high farm price. In case of importing a particular food crop, my model should suggest the best set of states to trade, so that the import price is very low. And some of the additional applications where this model can be used are to predict the what perishable food crop is profitable in a particular state in a specific season, or to help the traders to make high profit margins. And coming to acquiring the data, first of all, I need to check what are the factors that affect a particular perishable food crop. So, why different states will be having different yield and different food prices for a particular perishable food crop. So, I came with two reasons that affect the food price or the yield of a particular crop. So, those two are the weather conditions and soil conditions. India is a peninsular country. Almost all the three sides of India are surrounded by huge water bodies. So each and every state will be experiencing different climatic conditions and different soil conditions. Soil conditions. So these two factors will be affecting the price of a particular crop a lot. So in that weather conditions too, I have taken temperature, which is temperature, sunlight, rainfall, and humidity in the air. These all factors are primary, I mean necessary for growth of a particular food crop. For example, temperature or sunlight which is essential for photosynthesis, and rainfall, and all these factors do affect the growth of a plant. And the soil conditions and the soil profile and the wetness condition in the soil to affect the growth of a particular perishable particular crop. So I have taken these two into my consideration. And coming to the data sources, I have collected the monthly data of different perishable food crops at different states across the country from National Horticulture Board of India, and this is an open source data. And I do have downloaded all the data sets in my Google Drive, which you can um, which anyone from the UMBC group can access or go through if you want to go take a look into the data sets. And coming through the attributes of the dataset, each individual dataset consists of 6 different attributes, and these 6 different attributes are namely center name is the place or the center at which the data is collected, and the year and the month at the time when the data is collected, and W sale average price is the average sale price per quintal, and the retail average price is the price at which this data is actually collected at the centers where the middlemen buy the crops from the farmers. So the sale price is the sale price which farmers sell to these middlemen, and the retail average price is the price at which the middlemen will sell those to the government. So, and I do have the column of the total quantity of arrival in my data sets too. And in my project, I have taken only the top 10 most produced perishable food crops in India into consideration, because I want to train my model on this, and if it gets implemented, I want to extend the total number of crops into my model. And coming to the weather data sets, I have collected the monthly historical weather and soil reports of each and every state in India from starting from January 2010 till December 2020. And the source for for my data is NASA's data access sphere, and the link and the Google Drive for the data sets are described here. And coming to the attributes, I have all surface part total, which is nothing but photosynthetically active radiation, which the bit that amount of sunlight that a particular plant gets uh, plant gets from the sun, so which can be used by the plant for photosynthesis. And the dew frost point at 2 meters. Dew frost point is nothing but the temperature, or the temperature at which a the water moisture condenses into the frost. So this basically gives the idea about humidity and altitude of the particular state. And I have collected the temperature, minimum and maximum temperatures, and specific humidity at 2 meters. And I have also collected the precipitable water, or the rainfall, and soil surface soil wetness, and root zone soil wetness profile, soil moisture from this um, NASA's data access viewer. And after collecting the data, I have done exploratory data analysis. First of all, I have each a different data set. So first, coming to crops data sets, I have downloaded 10 different CSV files related to 10 different crops from 2010 to 2020. So in total, I am having 100 different CSV files, and I have to do a lot of data transformation among these files. And I did the transformation such as deleting unwanted columns, reshaping it, and deleting unwanted characters using regular expressions and so on. And after transforming the data, I combined all the data frames into a single final crops data frame. And coming to the weather data sets too, I have downloaded 10 different CSV file relating to 29 different state soil and weather conditions in India. So in total, I'm having 290 different CSV files, and in that too, I do have to do a lot of data transformation in order to um, make these two data sets combine into a single data frame, and uh, which can be read and be used for the further model preparing for the um, machine learning training. And after combining these two data frames, there are in total of 17 different columns and 30,000 rows. And coming to the data types of each different column, I have one int type, 13 float type, and three object data types in my um, final combined data frame. And if you look at into some visualizations in the data set, so in the final combined data set, so this is the visualized bar plots of different crops, the count, I mean the number of rows related to um, different 10 different perishable food crops. So if you see that there is an uneven distribution among these different food crops. So what I came to a conclusion from this is that, as some crops will be grown only in some particular season, for example cabbage, which is mostly grown in summer, or mostly grown in summer, or no sorry winter or spring season, so it's not grown in the summer season. So they most of the states might not be producing in summer season, so the data might be missing in case of cabbage. So in case of onions, these do grow in all the seasons, so the number of data, the number of rows relating to onions are more compared to that of cabbage. And this is why there is some uneven distribution of the data in different crops. And coming to the heat map, um, there is from this we can see that there is no much correlation among the data sets. There is correlation, but only among um, features. For example, between min max temperature, or um, soil wetness profile, ground level, top root level soil profile, and ground level soil profile. For these, for us, only some features there is a correlation. From this we can say that there is no need to do any feature selection, or do principal component analysis, as we might be losing some information from the data if we go for feature selection. And after plotting the box plots, I have checked for the outliers, and for sure there are some outliers in the data, and I have removed these outliers using interquartile ranges. After removing the outliers, the number of rows in my data are 22,120. Almost there are 6,000 rows of outliers in my data. And I plotted the line plots to check how different crops, um, how the similar weather conditions affect different crops. So, for example, if you look at this bitter gourd and okra, the temperature, the price of bitter gourd had increased from 2011 to 2012, but the price for brinjal has decreased from 2011 to 2012 under similar conditions of under similar weather conditions. This can state that. From this I came to a conclusion that different um, crops respond differently to different weather conditions. And if you look at the average price of different crops from 2011 to 2020, um, chili and peas are having high price relatively compared to the crops like onions or brinjal. And moving to the machine learning. So I initially performed some regression analysis on my data set to predict the farm price, but the root mean square error is very bad. So what I thought to do is to um, improve the accuracy by generalizing the training model. So what I tried to do is to from my final data set, I tried to divide the data set into 10 different crops data set, and for each individual crop data set I tried to divide it into four different categories, such as huge loss, profit, and huge profit. And I have done it based on the 0th, 25th, 75, and 100 um, percentile values of different crops. And what I thought to do is, if I am for a for if I am given any new data set which the model hasn't seen, and if the model is able to classify whether that given crop will fall into fall into any of these four with high accuracy, then I can train that data set with the model which is trained on that specific profit loss statement and the specific crop, and predict good value good mm, uh, and I thought that the model will be much accurate by doing this. So for that, what I did is I created a loss statement based on the market price of the crop, and I have divided the farm price of each crop into four different slabs. As I said here, based on the um, based on different percentile value. And then after that I used one hot encoder to encode the categorical feature value. As we discussed below, there were three different object data types in the dataset, as we discussed earlier, and I converted those three different categorical feature values into arrays using one hot encoders. And then one hot encoder, and those vectors were again appended to the data set. And then after, I split the data into train, validation and test data set in 80 is to 16 is to 4 proportion, and then standardized the data using standard scalar feature from sklearn pre-processing. And after doing that, I didn't get a desired accuracy value. So what I thought to do, I mean, there is so much bias variance trade-off in the data set. So I thought to do some more, include some more thing to the data in order to make it more accurate. So I have added two new features into the dataset. So if you look in the dataset, in the original dataset, I have taken the price of a particular crop in a particular year. So for the price might vary. I mean, the rupee value at in 2010 might not be same as the rupee value in 2020. So for that, I have to generalize or normalize the rupee value. In order to do that, I have taken the daily rupee exchange value from 2010 to 2020 and divided that by the current the price at which the crop is sold. So by this, I got a generalized or the normalized price for the crop. And the um, um, so I overcome that by adding this. And I have also added average wind speed for each month from 2010 to 2020 across different 29 states in India, because I have recently, while going through one of the documents, I came to know that wind speed really affects the growth of a plant. Because if if a plant is not having sufficient wind, the group's roots won't grow deeper into the soil. If there is high wind, the plant generally grows deeper into the roots grows deeper into the soil in order to stabilize the plant, and this in turn absorbs more amount of nutrients from the soil. So thus this helps in growth of the soil. So I have added these two new features into my data. And I have done hyperparameter tuning based on the learning curves. And for example, if you see that for the standardizing parameter C, um, the accuracy of the training model and the validation model is high when the parameter is set to 10 power 0 10. And in case of the decision trees, the maximum when the maximum depth is at 12, the test and training accuracies are higher. And if you go further, coming to the train and validation accuracies, these were the training and validation accuracies. These weren't good as I predicted. And but still, I moved forward with my original concept of training training the ML model based on this classification. Even though this classification is not that accurate, I proceeded forward and calculated the root mean square error for each and every different crop data set. But and I calculated the average value of all the root mean square error values. But it still didn't give me good results. It's same as that of the original regression, which is applied on the entire data set without classifying it. So I thought to implement deep learning, which I will be discussing later. And hereafter, I try to implement Spark. This in the exploratory data analysis or in data transformation, in my case is taking too much time. Now it's almost taking 20 minutes just to do the data transformation phase. So I try to reduce this by bringing Spark into the picture and running everything on top of Spark. So in order to utilize Spark completely, I have to run. I have to change the data frame from Pandas data frame to PySpark SQL data frame. And I also moved from. So while doing this on Apache Spark standalone mode cluster, I face some problems because of the immutable nature and inability of the Spark to maintain the row order. So I have to use pandas in between for some data transformations, and I tried to overcome this issue with the help of Coalesce. And Qualys generally is implemented on top of pandas and Apache Spark. So it's a lightweight API which is run on top of pandas and Spark, where it takes the data frame from pandas and as in case of as such as pandas, and it creates new instance whenever a new um, data transformation is done on top of that data frame. So but I tried to do it with the help of Qualys, but I still didn't achieve my desired result, as Qualys only have almost 60 to 70% functionalities of Panda. So I weren't able to, I am not able to do it completely with the help of Qualys too, but still with the help of this Park SQL data frame. But even with the even while running it along with pandas, I'm able to reduce the runtime from almost 20 minutes to 15 to 16 minutes. This isn't much effective, as I'm running that on standalone mode cluster, and my data is too small. I mean, it's just 30,000 rows. So um, the Spark might not be that effective for this small amount of data. And finally, I implemented deep learning, and I trained the model with the TensorFlow deep learning framework, and the final root mean square error is 8.185. This might not be that effective. I can say that my model is not that effective, but still, if we try to bring some more features that might give some more information regarding the prediction, I think then we can move forward in the further analysis. Thank you.